Okay, guys, let's continue looking at Module 00105, Introduction to Construction Drawings in the NCCER CORE curriculum. This is going to be section 1.3.0, Dimensions and Drawing Scale, and 1.4.0, Measuring Scales. All right, some trade terms you need to become familiar with. Look at this: engineer scales and architect scales. And what is scale? So scale is where we want to take a building or anything to be built to a certain size, and we've got to scale it down where it will fit on a piece of paper that I can give to you, and you take and scale it up and build it into the real world as the actual size. So what they'll do is they'll do some things like when they scale it down, they'll put what they used at the bottom of the plans, and it may say 1/4 of an inch equals a foot, or 1 inch equals a foot. That's your scale. So if I looked at the bottom of the plans and it said 1/4 of an inch equals a foot, and I was trying to figure out where to put this piece of equipment in this room that was marked on the plans, I could measure off the wall to where that piece of equipment was, and if it was 1 inch off that wall and the scale was 1/4 of an inch equals 1 foot, that would mean that it was 4 foot off of that wall. And I just keep scaling around walls and dimensions like that to make sure everything's placed in the correct place. And when things are not drawn to scale, they're marked NTS, not drawn to scale. Describes the drawings that show relative positions and sizes only without scale. Dimensions, it says always take great care when making measurements and be certain that you are measuring the correct point. This can be challenging when the drawings have been reduced in size. Triangular scales or tri-scales are most popular because they reduce the number of scales needed to be available. Drawing scales often differ from page to page in the same set of plans. Having one scale ruler like this gives you 6 of them at once, which is more convenient. It says that an architect scale for inches and feet breaks the scale increment values such as 3/8 of an inch into 12 equal parts to represent the inches. And then metric scales are always calibrated in units of 10, the basic for the metric system. And right here, looking at this engineer scale on the end right here, we can see where it's triangular shaped, and that's why this one ruler would give me 1, 2, 3, 4, 5, 6 different scales on one rule. And then they have them digital ones too that we can get. But it says engineer scale is always calibrated in multiples of 10, and the measurements are taken in decimals. All right, and some review questions for that section. It says, on a floor plan, a scale showing that 1/4 of an inch on the drawing represents 1 foot 0 inches would read 1 foot equals 1/4 of an inch, 1/4 of an inch equals 1 foot, 1/4 of an inch equals 1 inch, or 1/4 of an inch equals 1 foot. That would be 1/4 of an inch equals 1 foot. It says the scale used to develop site plans is an architect scale, a metric scale, an engineer scale, or an inches scale. That's going to be an engineer scale. All right, then it says common lengths indicated on metric scales are 3 and 6 millimeters, 30 and 60 millimeters, 30 and 60 centimeters, or 300 and 600 centimeters. I'm going to say 30 and 60 millimeters. All right, then it says that the blank scale must accommodate very large measurements. Is that an architect scale, a metric scale, an engineer scale, or a metric architect scale? I'm going to say engineer scale. All right, all drawings are drawn to scale. True or false? Well, that would be false because some drawings are NTS, or not to scale. All right, that's it for that section, guys. So the next part will be 1.5.0, the 6 types of construction drawings, and I will see you there.